Welcome to The Explainer. So, have you ever wondered why a field that looks, perfectly green and healthy can end up giving you a really disappointing harvest? Well, today, we're going to dig into the hidden science that might just be the key to unlocking a plant's true potential.
Okay, let's start with a puzzle that a lot of farmers run into. Picture this. You've done everything right. You've applied the main fertilizers, nitrogen, phosphorus, potassium, the whole deal. The field looks great, it's green, but the yield, it's just not what it should be. So what on earth is going on?
Well, a lot of the time, the problem is something called hidden hunger. The plant is missing a tiny but absolutely crucial ingredient. And one of the biggest culprits behind this hidden hunger? A simple lack of available zinc.
Now, a zinc deficiency, that's not just some minor problem. It can lead to some really devastating symptoms. We're talking about starving the plant of its ability to create energy and grow. It ends up stunted, weak, just crippled, really.
Okay, so the obvious question is, why not just add more zinc to the soil? I mean, if the plant's hungry, feed it. Simple, right? Well, it's actually not that simple at all. The real challenge is that the soil itself can actually work against you.
See, it all comes down to soil chemistry. It doesn't matter if your soil is acidic or alkaline, there are all these different compounds just waiting to pounce on inorganic zinc, like what you find in zinc sulfate. They literally grab onto it and turn it into something insoluble. They basically lock it away in a chemical jail where the plant's roots just can't get to it.
So this is where the science gets really, really clever. We need a way to protect the zinc to shield it on its journey from the soil all the way into the plant. And the answer? It lies in a very special process.
It's a process called chelation. And the best way to think about it is like putting that zinc nutrient inside a tiny protective bubble. This chelator, it's an organic molecule. It just wraps itself around the metal ion and boom, it's stable, it's water-soluble, and it's completely safe from getting locked up by the soil. And the real hero of our story today is a super powerful chelating agent called EDTA. What it does is form this incredibly strong bond with the zinc ion. It basically acts like a personal bodyguard, making absolutely sure that the zinc gets delivered safely right to the plant. Now, what makes EDTA so amazing is just how versatile it is. It creates this super stable complex with zinc, protecting it in all sorts of soil conditions, from acidic to alkaline. But here's the best part. When it finally reaches the plant, it releases the zinc exactly where it's needed. It's kind of like a smart delivery system for plant food. Okay, so with all these cool properties, you can probably guess that EDTA has a major advantage over traditional fertilizers. So let's actually take a look at the proof. Let's see just how big that difference in performance really is. This right here really lays out the practical advantages for anyone in the field. With zinc EDTA, what you're getting is way more reliable nutrient delivery. You have fewer headaches with compatibility issues when you're mixing products. And it's even safer to apply directly onto the leaves. Honestly, it's a total game changer for managing your crops. And get this, the efficiency gains are just massive. Studies have actually shown that because this chelated zinc is so much more available to the plant, you need up to 8 times less of it to get the exact same result as you would from regular old zinc sulfate. 8 times! So the big takeaway here is that EDTA is pretty much in a class of its own. I mean, look at that ratio. Its superior efficiency means you can use way less product to get the same or even better results. And what does that translate to? Well, lower costs, less waste, and a much more sustainable way of farming. All right, so we've got the science down. Now let's get practical. How do you actually use this stuff out in the field? Let's dive into some of the products and the different ways you can apply them. So whether you're a fan of liquids or you prefer powders, there's a zinc EDTA product out there for you. The powder form, I gotta say, is especially cool because it dissolves so completely. That means you don't have to worry about your equipment getting clogged, which, saves a ton of time and money. And another great thing about zinc EDTA is just how versatile it is. I mean, it's a trusted solution for a huge variety of crops. It's especially valuable for those crops that are really sensitive to zinc deficiency. Things like corn, citrus, pecans, you name it. It really helps ensure you get that healthy, abundant harvest you're looking for. So how do you use it effectively? It's a pretty straightforward 4-step process. First things first, always test. You gotta know what you're dealing with in your soil or your plants. Second, pick the best application method for your operation. Third, apply the right rate based on how deficient things are. And finally, and this is crucial, timing is everything. You want to apply it early in the growth cycle to get the absolute best results.
And of course, we have to talk about safety. Just like with any agricultural product, safety is number one. It is absolutely vital to follow all the handling and storage instructions. That means wearing your protective gear, using the right kind of storage tanks, and, this is a big one, always doing a simple jar test to check for compatibility before you try a new tank mix. Better safe than sorry, right?
But, to really get the full picture here, we need to take a step back and look at the environmental side of things. Because powerful solutions, well, they often come with some really important considerations.
And this is where the story gets a little more complicated. See, the very thing that makes EDTA so incredibly effective, its amazing stability, also means that it hangs around in the environment for a really long time. So its persistence is kind of a double-edged sword.
So because EDTA is just so good at grabbing onto metals, its persistence raises a big question. There are concerns that it could potentially stir up and move around heavy metals that were otherwise safely locked up in the soil or sediment. And this is definitely an area of ongoing scientific research.
And all of this really brings us to a crucial question for the future of farming. I mean, technologies like zinc EDTA give us the power to be more precise and more efficient than ever. But as we try to feed a growing world, we also have to be really mindful of our long-term impact on the planet. And finding that perfect balance, well, that just might be the great challenge of our time.